right, the last few lessons we've kind of just concerned ourselves with the arcs. Okay, we've been talking about some angles. All right, we've talked about angles and arcs basically. So we've been dealing with degrees, things measured in degrees. Okay, so finding missing angles, finding missing arcs, subtracting arcs, adding arcs, dividing by 2, and all that good stuff. All right, today what we're going to do is we're going to talk about the actual lengths of the line segments. So we're going to have tangents, we're going to have secants, and all that kind of stuff. We've actually talked a little bit about line segments already with a couple tangents. So let's say I had a point out here and I wanted to draw this tangent to the circle. So this is just a quick review, just to show you that we've already discussed just a little bit about the lengths of line segments so far. And so if this was tangent, that would hit about right there. And now remember what we said. If we had a point outside the circle, which is that point right there, and this line is tangent and this line is tangent, what's true about these two line segments? What's true about A, B, and AC? Say it. They're the same, exactly. Okay, so we said that this was equal to this, set them equal to each other, no big deal. Do you agree? Yeah? Yeah. All right, so we have actually talked about the lengths of the segments. So this is not like the first time we would have talked about it, but we're going to get a little bit more involved and do a little bit more with this. So let me get a nice big circle right here, and we're going to put some in here. We're going to do a couple secants. Now the secant, we're going to stop it on the circle itself. So we're going to go from one part of the circle to the other part of the circle. So even though a secant is technically a line and it goes all the way through, we're going to start here and end here. So that's like a segment. That's a part of a secant, right? Because a secant technically is a line that keeps on going forever, but we're just going to go from here to here. So we could still say it's a secant. So if I have two secants that intersect, now this looks very similar to what we did yesterday, doesn't it? We said, oh, if you had two secants that intersect inside the circle, then that angle right there is equal to half the sum of the two arcs. But we're not talking about the angles this time. We're not talking about the arcs. We're talking about the actual lengths of the segments that are formed here. Everybody see that? So what I'm going to do is I'm going to put some letters here. And I'll put like a little A right here. Now if I put an A right here, that represents from the circle to that point of intersection. Everybody see that? All right, and then I'll put a little B right here. Everybody got that? So you know what I'm talking about when I say segment B. Now I could have put a big capital A and all that and used two letters to represent the lengths. I just think it's a little easier to do it like this. And let's make this another color. So if I call this segment A and this segment B, I'm going to call this segment C and call this segment D. All right. Now I kind of drew it so it kind of looks like A and C are equal to each other. That's not necessarily true. I just happen to draw it like that. Okay, I probably wish I didn't do it, but anyway, it doesn't mean that A and C are equal and B and D are equal. Okay, that is not necessarily true about this. I guess you could have a situation where that's true. It's not necessarily true here. All right, so don't look at this and say, oh, A and C are equal. No, they're actually not. Not in general anyway. So just kind of keep that in mind. We do have a relationship though, and this is probably a relationship you probably would have never thought of before in your life. Jacob, you getting all this? Mm-hmm. All right, head up please. Thanks. All the blood's going to be rushing to your head and you're going to have a headache. All right, so keep your head straight up and let's pay attention. So I've got A and B right here, and I got C and D right here. Here's a relationship. I'm not going to go through a proof and show you where they got it from or anything like that. Let's just tell you what it is. If I take A and multiply it by B, that's going to equal C multiplied by D. There it is. Simple little relationship. It's one that I don't know if I would have ever come up with on my own, but this is what they tell us it's true, and it is. If I take the length of segment A, whatever the length is. Now, we're not talking about angles, are we? We're not talking about arcs. We're not talking about angles. We're just talking about the length of these segments. If I take the length of this, of A, and the length of B, and if I multiply them together, all right, if I multiply them together, that's going to equal C times D. Does that mean the length of this A plus B, this whole secant right here, does that mean that length of this secant is equal to the length of this secant? No. All right, but it means if I multiply the two segments together, multiply these two together and multiply C and D together, then that product equals that product right there. All right? Simple little situation. Well, they'll tell you. They'll like leave one out. They'll give you 3, leave one out, and you got to find the 4th one. So let's put some numbers in. Let's see. Let's get rid of these letters. Let's put some actual numbers in here, and we'll see what we got. Let's see. A nice easy one. Okay, they'll say this is X and this is 10. 5 and 12. 5 and 12. All right. What's that? Oh, you figured it out already? Okay, good. Yeah, it's not that hard, but I want to show the work, all right, just so everybody sees where we got that from. So what do? We take the two segments of this one secant, multiply it together, take the two segments of the other secant, multiply them together, then set them equal, and then solve for whatever you need to solve for. So let's do this one first. So I've got x times 10. So how would I write x times 10? Just 10x. And then I've got 5 times 12. I'll tell you what, I'm just going to write it out so that you see where we got these numbers from, all right? I mean, you could probably just done that in your head, but that's fine. We'll write it out. So I've got 10x equals what? 60. Divide by 10, divide by 10, x equals 6. There you go. And you were right. You said 6, and that's what we got. Remember I said that this segment and this segment aren't necessarily equal to each other, and that just shows right there that they don't have to be equal to each other. I mean, they could be, depending on what numbers they give you, but they're not in this case. That's all there is to it. That's not hard, is it? Well, it's got to get harder than that, don't you think? You've been doing this long enough, haven't you, to know that it doesn't have to. Yeah, it might not have to, but you know it always does, though, don't you? Yeah. So let's, if I can get rid of all this without, there we go. Let's put some other stuff in here. Let's go orange this time. So they could get a little bit tricky with you. Let's do this. Let's make our secants look a little different because I'm tired of that look right now. It doesn't always have to look exactly like that. Like this secant, let's take it to here, and let's take this one to about right there. Okay? Now they're perpendicular, right? No, we don't know that. Okay? I was just trying to test you. All right, no, we don't know anything about being perpendicular, and even if it was, who cares? All right, because that's not really going to help us find the lengths of the segments in this situation anyway. What did I say? I was going to use orange. Okay, so let's see what we got. X plus 1, x plus 8. So this one right here is x plus 1, that segment, and this one right here is x plus 8. And then this one right here is x, and this one is x plus 10. All right, everybody with me? Let's scooch this up just a little bit. Have some room to write down here. All right, so we have to solve for x. That's what they tell you to do. Yep, it says find x. So we could do what? Multiply these two together, multiply these two together. It doesn't matter. Let's do the x plus 10 and the x first. All right, so there's x times x plus 10. Make sure you put that x plus 10 in parentheses, you're right, and then you have to distribute the x through here. Good. All right, and let's multiply these together. So that's x plus 1 up there. This is x plus 8. Make sure you put them in parentheses. It's very important. I'm not doing that just for fun. All right, I'm doing that because it's important that you put it in parentheses for the next step. Everybody see that? It's not too hard, is it? Setting it up? No, it's an easy theorem. It's no big deal. But we got to do some math here. So let's do a little distributive property here. So I've got x squared plus 10x equals, what about this thing? I think we mentioned this yesterday, didn't we? Didn't we do a problem like this yesterday? Yeah, FOIL method. Good. So let's do that. So it's going to be x squared plus what? Outside is 8x. Inside is 1x, right? Or just x. Then the last is 8. All right, let's see what we can do. This works out real nice. It kind of worked out like this yesterday as well. You have an x squared on this side. You got an x squared on this side. What can we do with both of those? Yeah, I hate to say cancel too much. In this situation, I don't want to really say cancel out. What are we doing to get rid of the x squared? Subtracting, right. So let's say subtract an x squared, subtract an x squared. I mean, in effect, yeah, it does cancel out, but I want you to know what we're doing to cancel them out. Because there's a lot of different types of situations where we say cancel out, and I try to be careful and make sure you understand why they cancel out instead of using that too often. Okay, let's do this. Let's 10x equals, let's add up some like terms here. That would be 9x, and that would be 8. Would you agree? Subtract a 9x from both sides. That goes here, and subtract a 9x from that. That's x equals 8. Boom. There you go. There's our answer. Pretty simple, isn't it? Now, they could, they don't do this on this particular example, but they could do something like this, couldn't they? They could say, what's the length of DE or something like that. But you've done that plenty of times this year, haven't you? You solve for x, then you plug it back in. So what would DE be equal to? 8. 18. Let's do this in a different color. So right, DE would be 18. Of course, we just found X, so we know that's 8, right? What about this? This is X plus 1, so this would be what? 9, and this would be what? 16. I don't know, just for fun, let's find out what the lengths of these are. What's 9 and 16? It's 25, right? So AB, right? They could ask you that, couldn't they? They could say, what's the length of AB, line segment AB? And so that would be 25. What's DC equal to? Oops, C. And that would be 26, wouldn't it? Now remember what I said earlier? These segments of the secant don't have to necessarily be equal to each other. All right? And a lot of people think that. When I go through this, I think, oh yeah, this segment and this segment right here, they got to be equal to each other. No, not necessarily. You can see right here that they are not equal to each other. All right? Sometimes they could. All right? It's not like they can't be. They could be, but they don't have to be. All right? And a lot of people think that they have to be. Just because the products of the two segments equal each other does not mean that the whole entire segment has to equal this whole entire segment. All right, enough of that. We good with that? That's pretty easy, isn't it? Yep, I think so. All right, so when does this situation occur? This situation occurs when they intersect where? Inside the circle. All right, so what do you think we're going to have? Actually, let's... Yeah. What do you think we're going to do now? We're going to have a couple secants that intersect where? Outside the circle. Okay, you kind of see a lot of relationships between what we did yesterday and today, but really the math is completely different because we're talking about the lengths of the segments today. Yesterday we talked about the arcs and the angles. All right, so two completely different things, but our pictures look exactly the same as they did yesterday as they did today. It's just we're solving for different stuff, that's all. All right, so here's a nice big circle again. Actually, I don't want to make it too big. So I'm going to draw a couple secants. See what I want to do. Yeah, let's just draw a couple secants. They talk about a couple things at the beginning of this. I don't know if it's really necessary. Watch, I'm going to draw a secant, but I'm going to stop it right on the circle. Remember, a secant technically keeps on going all the way through, but I'm going to stop it right on the circle. So it starts from a point outside the circle, and it goes all the way through the circle and hits the other end at a point right there. Everybody with me so far? Okay. I'm going to use these little letters. If you look in the book, they don't use the little letters. They use the points on here, and I don't know. I like the little ones better. So now, if you read the theorem in the book, it gets a little wordy. I'm not even going to sit there and read it. Okay, if you want to read it, you can. I have my own little way of explaining this. Okay. Let's put some segments on here. We'll call this segment A. Now, where is A? Starts from that point out here, and it goes all the way to that first point where it hits the circle. Would you agree? All right. And then I'll call this little bit B. Then I'll call this one C, and I'll call this one D. But I also want to name something else. I want to name the whole thing. We'll call this E, and we'll call this whole thing F. Okay? Because I'm going to use that whole entire segment. So watch very carefully. Okay, I'll keep the same color. So what do? We're looking for lengths of segments, okay? So what I'm going to do is this. I'm going to take the whole segment, right? The whole entire thing. Actually, you know what? Let's not use the E or the F. Let's just add them up and show them like this. Watch. Let's not start with the whole. Let's start with the outside. You see how you have an external segment, you got an internal segment, all right? So this is the outside and this is the inside. A would be the outside segment, B would be the inside segment. Everybody with me? Rachel, you getting all this? Then C is the outside segment of this one, and D is the inside segment here. So we got outside, we got inside, all right? They call it external, internal. I'll call it outside, inside. So what we do is we take the outside segment and we multiply it. Okay, kind of like what we did before, right? You don't just go A times B, though. You take the outside times the whole entire secant. What's the whole entire secant? Is it AB? A plus B, right? So it's A plus B. It's very important that you understand that. Because I don't find this whole length from here to here by multiplying those two together, do I? I add them together to find that whole length. So if I take the outside times the whole thing, and this, I'll say this a lot. I'll say the outside times the whole thing. All right, I'll even write that in there. The whole thing, okay? So the outside times the whole thing equals, what do you think? The outside times the whole thing of the other one. Right. So give me some letters. Nate, you're about to do it.
C times C plus D.
Very good. C times C plus D. Everybody got that? So you take the outside segment, which in this case is A, times the whole thing, which is A plus B. And then that equals the outside of the other one times the whole thing of the other one. And of course, what are they going to do? They're going to give you like 3 of the 4 things, aren't they? And you got to find whatever's missing. And so you set it up like this. All right, so these are going to be numbers. One of them is going to be a variable, probably. And you just set it up just like this. Tell you what, I'm going to write it without all those words in there. So it's A times A plus B equals C times C plus D. Again, in and of itself, this is not all that difficult. It's just keeping track of everything that we've been doing is the thing, you know, what's being added, what's being subtracted, all that kind of stuff. You know, what's being multiplied, what's equal to each other. It's all that stuff you got to think about. All right, so there you go. That's what the theorem says. Let's throw some numbers in there. Got a couple minutes here. Let's chuck some numbers in here and see what we get. All right, you've got all that written down, don't you? Draw another circle with another couple secants. I'm just going to use this one already since it's already up here. Let's call this one, let's go a different color. Let's call this one 8, and this inside one X. This one is 6. And it's not necessarily drawn to scale, but we can still do this with our numbers. Alright? So this outside one is 8, the inside one is X. This outside one is 6, the inside one is 10. Again, not necessarily drawn to scale, but that's okay. So what do? We take the outside times the whole thing. All right, I'll say that over and over again when I'm talking about these. Take the outside times the whole thing. Does that make sense to you? So which one's the outside? 8 times the whole thing. What's the whole thing? It's 8 plus X, right? Or I like to write X plus 8. It's not 8X. Everybody see that? It's a common mistake a lot of people make. A lot of people say, oh, 8X, that's the whole thing. No, it's not 8 times X, it's 8 plus X. It's the whole, if I add the two things together, that's the whole segment. All right? Then I do the same thing down here. So I take the outside times the whole thing. What's the whole thing? 6 plus 10, right? And we know we can do that in our head, but I'm going to write it down like this just since I'm teaching it to you for the first time. All right? So now we just do some algebra and we solve for X. Let's do it real quick. So 8X plus, what's that? 64 equals, that's 16, isn't it? 16 times 6, what's that? Is that 96? Somebody do that. 16 times 6. I think it's 96, isn't it? Somebody do that. Nobody's moving. Nobody's got a calculator? You got a calculator? I think it's 96. Okay, good. Sometimes I doubt myself when it comes to arithmetic. Subtract 64 from both sides. 8x equals, that's a 2, that's a 3, so that's what? 32. Divide by 8, x is what? 4. There you go. Now, they just ask you to find that, so x is 4. Again, it's not drawn to scale, but that's okay. They could do this. They could say, this is A, B, C. What's the length of AC? All right, so you find what x is, you add it to 8, and that's what? It's 12. All right. Now, do these segments, does this secant right here and this secant right here, do they necessarily have to be equal to each other? No, not at all. Because this is 12 and this one's what? 16, isn't it? All right, so they don't have to be equal to each other. All right. There are situations, I guess, where they could be equal to each other, but they don't have to be. Make sense? So again, what do? Take the outside times the whole equals the outside times the whole thing. If you can remember that, you can do those problems. All right, let's see what else we have. We got one more, I think. Let me double check. Yep. This is, now on that one we had 2 secants. This one we have 1 secant and something else. What else? Tangent. That's right. We have 1 secant and 1 tangent. So let's draw the secant first. Now again, we're going to take it just to the circle, right? Again, technically the tangent keeps on going, but we're just going to keep it right there. And then this one's going to be tangent. So that's a secant, and watch, this is a tangent. So I'm going to stop it right at the point of tangency. Right where it hits the circle. That's the point of tangency. All right, secant, tangent. Let's put some letters in there. I'll call that A, I'll call this B, and I'll call this C. All right, so this time we only have 3. Now this is very, very similar to the 2 secant thing. For instance, this part right here, the secant, it works the same way as we did before. So what do you think the secant part is? What am I going to do? I'm going to go B times what? B plus C. But look at the tangent. It doesn't have an inside segment, does it? Everything's on the outside. So what we're going to do is we're going to take the outside times the whole thing. Well, the outside is the whole thing, isn't it? So what do you think we're going to do? We're going to square it. Exactly right. We're going to take the outside, which is A, times the whole thing, which is what? A. What's A times A? It's A squared. Does that make sense? So it really kind of follows what we just finished doing with the outside times the whole thing. All right. So the outside and the whole thing is the same thing. So I go A times A, which is A squared. There it is, right there. That's hardly any different than what we just did, is it? Not much at all. Think you got that? You want some numbers in there? Of course you do. Say yes, I want some numbers. I want to make sure I know how to do this with some actual numbers here. So this is, the outside is x, and the inside is 7, and the tangent is 8. All right, there we go. So what are we going to do here? Yeah, I like the x on the left-hand side. So, I mean, you can square the tangent first if you wanted to, but I like to do the one with the x first. I don't know, that's just me. So I take what? If I do the x one, what am I going to do? X times what? So I take the outside times the whole thing. So the outside is x times the whole thing. Say it. X plus 7. Good. All right, so that's the outside times the whole thing, correct? Equals, what do we do with the tangent, though? We just square it, right? And I'm gonna write it like this just so we can see, right? I know you can do that in your head, but we'll just keep it like this. So now you just solve for x. So what do we got? X squared plus what? 7x. Ooh, we got some fun here. Here's some fun algebra. Equals 64. Now, we got x squareds here, but we can't just cancel out the x squareds like we did on that other problem, can we? Because we don't have an x squared on the other side. This depends on how much of this you had in Algebra 1. Some Algebra 1 classes do a lot of this. Some don't do any of this. Some do just a little bit. All right, this is fun. I'm glad you agreed, Demir. All right, so what we're going to do is stick this on the left-hand side, set it equal to 0. Do you remember doing any of this? No? Try to factor it. Do you remember factoring quadratics from Algebra 1? Where you put the two sets of parentheses. Do you remember that? It's kind of like backwards FOIL method. No? I'm getting blank stares. I guess that means you didn't do it.
Yeah.
Did you do, I guess you didn't do quadratic formula then either, did you? You looked at it? Okay. I probably wouldn't put this on a test or a quiz, all right? But this is for what? Come on. You guys are slow. This is just for what? Thank you. Thought that would be on the tip of your tongue by now. Yes, this is just for fun. All right, over 2a. Does that ring a bell at all?
So what you don't think if you
Does that ring a bell? You guys are. It's not algebra 5. This is algebra. This is like algebra 1b, if you want to call it that. It's kind of like halfway between algebra 1 and algebra 2. You'll do a ton of this in algebra 2. I'm running out of time, so I got to go through this real quick. Watch. What we do is we look at the numbers out in front. So the first number out in front of the x squared is a, this one is b, and this one is c. So basically all you do is just plug those numbers in for whatever these letters are. Now it says negative b means the opposite. So if b is 7, what's the opposite of 7? It's negative 7. Plus or minus square root. B squared, so that's 7 squared. What's 7 squared? 49. Minus 4 times a. What's a? It's just a 1. What's c? It's negative 64. Who's got a calculator? Over 2 times a, or just 2 times 1. All right? Watch. It's negative 7 plus or minus.
how do you know what to pick?
It's both. You pick both of them, the plus and the minus. So what's this? What's 64 times 4? Somebody do that real quick. What's 64 times 4? Quick, quick, quick. 256 plus 49 gives you what? 305. Okay? And then that's over 2. It's actually two things. Watch. On your in your calculator, you'll go negative 7 plus the square root of 305 over in 2. You'd throw that in your calculator is what you would do. Then you would take negative 7, what do you think? This is plus or minus the square root of 305, put it over 2. And I'll let you do that on your own. According to the book, I don't know which one's which. Hold on a second. I think this is probably 5.2, and this is probably, I don't know which one's which. Negative 12.2. Did you get those? Did anybody try that on your calculator? It's not that hard. Put this in your calculator, you're going to get one of these answers. Okay, put this in your calculator, you're going to get one of these. Okay, my guess is that one's that one, and this one is that. And that would be your answer. Okay, but the problem is, you're trying to find the length of a segment, aren't you? You're trying to find a length of a segment. Is there any way that you can get a negative length? No. So what you do is you just throw that out. Remember we said plus or minus? So we got to figure out which one. So it's not going to be the minus. What's it going to be? It's going to be the plus. So it's going to be 5.2. Let me give you some problems to do.
So if they give you a number in the square root, like, so what do you do?
Put in a calculator. Put 305, hit square root.
Like at the start, like at the part that doesn't have inside in it.
This? I'm not sure what you're saying.
Keep going.
Where? Like right here?
No.
Right here?
Up to next one.
Where at? This?
Keep going up.
What are you talking about?
You know where the 8 is?
Yeah.
At the top.
Right here?
They just had like 174 in the square root. Square root of 174.
Well, then that's easy because, like, if this was, watch, if that was the square root of 8, what do? Take the square root of 8 and you square it. What's,
Same thing.
it's just 8, right? Yeah. So actually, if they make this a square root, it actually makes it pretty easy. All right, because it's just that number inside the square root. Okay, now I see what you're saying. All right, let's see. What are we doing? 10-7. So it's 10-7. Yeah, that was Demir's fault for keeping us. I was going to let you go.
I told you.
Page 740, numbers 6 to 21. All right, 6 to 21. All right, have fun with that.